Algebra 1 students, welcome to your 9.2 notes, quadratic functions. We're going to go a little deeper on a topic that we've already begun. Alright, so today what we're looking at is what the middle term, bx, what impact it has on the quadratic graph, and you can see I've boxed that in right there. That's what we're focusing on. So when we're in the form y equals ax squared plus bx plus c, the value of b affects the position of the axis of symmetry, which of course then would also impact where the vertex is located. So in order to find the axis of symmetry, it's always going to be in the form x equals negative b divided by 2a. And we'll see how that works in a moment, but that gives you that vertical line that cuts right through the middle of the graph. Now to find the vertex, it looks a little weird here, negative b over 2a comma f of negative b over 2a. All that means is once you find this value right here, this x value for your axis of symmetry, plug it back into your function and that'll give you your point, your ordered pair that's the vertex of the graph. So let's give this a shot. Let's find the axis of symmetry and the vertex. So here we go at number 1. We'll know that x is equal to negative b. Well, in this case, we know this is a right here, this is 3, b is negative 6. So negative b, maybe we could say it is the opposite of b, would actually be positive 6 over 2 times a. And that's 6 over 6, so it's 1. So I'm going to actually write it down here. We'd say x equals 1. My next step is to go ahead and plug in 1. That's the axis of symmetry right there, by the way. But to find the vertex, I'm going to plug in that value we just found. So 3 times 1 squared minus 6 times 1 plus 5. And that gives me 3 minus 6 plus 5. That gives me 2 if my math is correct there. And so we get a vertex of 1 comma 2. So again, the process, negative b over 2a gives you the axis of symmetry. Then plug that x value that you found into the equation. All right, let's try another one. Notice here that a is equal to 4, but there's no b term. So we just say b is 0, c then is negative 7. So our axis of symmetry would be x equals, well, negative 0 is just 0 over 2 times 4, but really what we have here is an axis of symmetry of x equals 0. Then if I want to find the vertex, I just plug in that x value, 0 squared minus 7, that's negative 7. So our vertex would be 0, negative 7. Alright, pause the video, do number 3 on your own, compare your answer to mine. Alright, you can see my work here. I did x equals negative b over 2 times a. That gave me an axis of symmetry of x equals negative 6. Then I just went and plugged it in, so 1/2 times negative 6 squared plus 6 times negative 6 minus 3, and we get negative 21. You'll notice that this one was written as f of x, where the previous problems both had y equals instead of f of x. That's really not changing anything in our process. Just treat that f of x essentially as if it's a y. Onward. All right, let's take a look at this. We're going to use this same thought process to graph. We'll label the axis of symmetry and the vertex. So here we go. Let's start by finding that key information. The axis of symmetry, x equals negative b, which in this case would be negative 8, all over 2a, so 2 times negative 2. So our axis of symmetry is x equals 2. Now I could go ahead and sketch that line if I wanted to. I'll do that. Let's get a dashed one here. That'll work. It'll look something like that. Now that we know the axis of symmetry, I can go ahead and evaluate that function at 2. So that's negative 2 times 2 squared plus 8 times 2 plus 9, a little work there, but this is negative 8 plus 16, so that would be 8 plus 9, which would be 17. All right, so 2 and 17 is our vertex. Now this is a bit of an interesting situation when we're looking at a graph like this. So perhaps what would be wise would be, instead of just trying to put a point that we estimate to be 7 spots above, let's change our scale and let's actually count by twos on this graph so that we have a better idea of where we should be. Now that's going to mean I need to move this axis of symmetry over as well. All right, so here we go. We're going to be at 2 and 17. And let's see, 6, 8, 10, 12, 14, 16. There's 18, so it's halfway in between. It would be like right there. Now, the other thing that we know at this point is that the graph opens downward. We probably need a little bit more information than that. So what I'm going to do is go ahead and plug in some other values. And I'm looking at values that are near 2. So what I'm going to do is 0, 1, 3, and 4. We're going to evaluate each of those 4. As you can see here, I've skipped ahead just a bit by evaluating these 4 points, and now I can connect them on the graph, and we should get a parabola that looks something like this. Not the best looking graph that I've ever drawn. We'll try to clean that up and we'll roll with it. That's not spectacular, but it is the right idea. Should look something like that. All right, let's go on to the next one, number 5. Y equals positive 4x squared minus 8x plus 5. We start the same way. X equals negative b, which is the opposite of negative 8, so that's positive 8, over 2 times a, which would just be 8 over 8, so our axis of symmetry is x equals 1. All right, let's go ahead and put that axis of symmetry on there. It's going to be kind of close to the other graph, but we can distinguish. All right, and then we need to plug in that value, so our y value is going to be 4 times 1 squared minus 8 times 1 plus 5. That's 4 minus 8, so negative 4 plus 5 would be 1. So our vertex in this case is 1 and 1. And I'll go ahead and label that as well. Now the other thing I know about this graph, because the a term is positive, I know this graph opens upward. Again, I want to get a little bit more precise info. But it is good to note that the vertex is at the x value of 1. So I'm going to test points either direction of 1. Good points to test would be negative 1, 0, 1, we've already tested, and then 2 and 3. I'm going to pause it and fill this out and graph it. All right, you can see what I've done. I've filled out this chart to get the rest of my y values. Negative 1, 17, 3, 17, 0, 5, 2, 5. Notice the symmetry on these values too. If you pick good x values, you'll have symmetry here. It kind of cuts your work down a little bit. And then you can see what the graph looks like. Fairly steep graph that opens upward. All right, we have one more. Let's actually walk through this one all the way together. We will start by finding the axis of symmetry, of course. So x is equal to negative b. Now what's the b value here? That's kind of weird. It's 0 over 2 times 1/4, and really we don't care what's down here. We just know that it's x equals 0. And then our function evaluated at 0 would be 1/4 times 0 squared minus 6, which is just negative 6. So our two key pieces of information is the axis of symmetry at x equals 0. The vertex is at 0, negative 6. Let's go ahead and sketch that information. X equals 0 is this vertical line. It's going to blend in with the axis just a little bit. One piece of advice, if you just barely offset it, it makes it a little bit easier to see. All right, and now we'll go ahead and plot our vertex 1, 2, 3, 4, 5, and 6. All right, there's the vertex. The A term is positive 1/4. I know this opens upward. So what I need to do is pick some other values. And I want to work around 0. So -2, -1, 0, 1, and 2. I've gotten 2 places left of 0 and 2 places to the right of 0. Now I'm going to plug these in, and perhaps on this one I'm going to show a little more work. I've been doing a little mental math on some of the others for this step. For some of you that's fine, for some of you that may not be fine, so let's not skip that step this time. So we're going to have 1/4 times -2 squared minus 6. -2 quantity squared is 4, times 1/4 is 1, minus 6 is -5. Now here's the beauty of this. I know that down here at 2, I'm going to get the same value, and you could confirm that by writing it out, but 1/4 times 4 is 1 minus 6. All right, and then these other two, we're going to have 1/4 times either positive 1 or -1 squared minus 6, but either way, that's going to be 1/4 minus 6, which is -5 3/4. I'm fine with the mixed fraction if you wanted to write that as -23/4. If you're more comfortable with that, then that's lovely. Have at it. All right. So there are the outer points, -2, -5, and 2, -5. And then the points that are in between would be about 3/4 of the way closer to 6 than they are 5. And so this is a fairly wide parabola. It's going to look something like, well, let's try that again. That was pretty epic failure there. This will work a little better. It's harder than it seems to use this airliner and draw a parabola, obviously. All right, folks, there is your graph. That's the end of your 9.2 notes. Please make sure that you have written them down carefully. If you have questions, bring them to class and come ready to work. Have a great day.